Okay, um, so here's the deal. Part of you are having a problem because you're not consistently practicing, okay? You like practice right before the test. So let's look at an analogy, because I think analogies are really cool and they help us understand things. So let's say you wanted to play a sport. Let's pick football. It could be any sport. It could even not even be a sport. It could be like playing the piano, right, or playing the trombone, or playing the whatever you want to play, all right? But let's say that you're going through class and everything, and the only time you practice is when everybody's practicing. The teacher's leading you, and you're practicing, okay? But you don't ever practice by yourself. So really, do you know if you're any good? No, because you don't ever hear just you. You hear everybody else. You see what I'm saying? So, y'all, when I teach a section, what should you do? Yeah, you should go home and work about, 6 to 10 problems. Now, can some people work 6 problems and be okay? Can some people work 10 and be okay? Do some people need more than 10? Yeah, you do. It's okay. It would depend on what it, if it was math, I could probably do 6 to 10. If it was history, something, I would be doing it a lot. I'd be practicing a lot. Okay, that's not my skill. I'm not good at that. All right. So naturally, I would be good in math, right? Since that's what I chose to do. So you have to practice. You can't just like listen to me in class and then never ever practice and expect to be successful. You've got to go home and practice. Does it take long to do 6 to 10 problems every night? Some of y'all will. No, I would say generally it's not going to take you a long time. Okay? Now, which problems are you going to do? The odd problems in the book. And no, Nikki, I would not do the hard. I wouldn't start out on the hard ones because then you're just going to feel defeated. Okay? I'd start out on some easier ones, kind of build my confidence. All right?
I can't figure out the examples.
So, all right. Hey, do you need me? I haven't been over there. No. Sorry, you lost yours? They're not there. I don't know. Maybe someone has. Yes. We are talking about square roots and properties of exponents and roots and rational exponents. It is. It's pretty cool. The other kids liked it. They were kind of scared. They said it looks really hard, but I said it's not. But then they're like going, yeah, well, it's easy in here, but then the test is killing us. So I'm trying to tell them that, well, they're not practicing enough. They like don't do anything the whole entire time, and then like the night before the test try to cram and study. Like, you're not going to be a successful football player or band participant or anything like that if that's all you practice.
Start off with the very first one that you cannot do. Square root of x squared plus 4.
Square root of x squared.
They'll work out. I bet you they could do it. They'd say it's x plus 2.
That's right. That is not
right.
No, anything else. This is
not right.
Don't ever do this again in your life.
But I can say that 100 times and they don't listen to me. I don't know what it is. Yeah? I don't know. I'll talk about it later. Okay? We need to look at your major. Okay? All right. So properties of, evaluate square roots and properties of exponents. Let's talk about properties of exponents for just a second. Let me rephrase that. Should you already know properties of exponents? People, I've already taught it to you, okay? So this is going to be your lesson in 1 minute. A to the m times a to the n is equal to m plus n, okay? It took It took the whole entire class to get that right. Okay? There were more people that missed it than got it right. A to the m raised to the n. A to the m over a to the n. A to the negative m.
1 over a to the n.
Very good. Y'all, you should know all that. You should know all that. That's a review, okay? So 1 out of 4 is a 25%. That might be what you make on the test, okay? You got to know more than 25%, okay? Not much. You're not going to be successful, guys, okay? They're not going to give you credit for the course for 25%. They won't even for 50%. You have to know 3 out of the 4. 75%. You need to retain at least 75% of what we're talking about. Okay, what's the other thing we're going to do? We are going to evaluate nth roots. That means we want to be able to take any root, not just a square root, but what about a fourth root, a cube root, a fifth root, a sixth root, all those things. Okay? So any root. They call it an nth root. All right? And rational exponents. Now, what does rational mean? All right. So we are talking about exponents that are fractions. Okay? Exponents that are fractions. Okay, so the first thing I want to do is I want to talk about some things and make sure that you know the vocabulary that's going to be used. Okay? So the first thing I'm going to talk about is exponents. So like 2 to the third is equal to 8. Let's see if you got your math vocabulary. What's this 2 called?
Leading. No, that's in the... It's the number that
It's what it's sitting on.
The cube root of 8. The base?
Yeah, that's all it is. It's the base. Alright, y'all are worrying me. Y'all are the first class that nobody knew that in. Most all the other classes knew it. You got this one though, I know. What's this 3 called? Okay, an exponent. Now, what's this whole entire thing called? There you go, a power. That's called a power, a base raised to an exponent. Okay, so let's look at the other. Now, what's the opposite of exponent? How would you undo an exponent? A root. Not just a square root, but any root, okay? So, roots and exponents, they're opposites of each other. That's what we use to solve equations, okay? So here's this one. Okay? Looks like that. Now, I would venture to say that most of you do not know this vocabulary, okay? Y'all have known 1 word out of the 3 that I'm fixing to give you. So, does anybody know what that's called? He's called the radicand. He's under
the radical.
Yeah, the radicand goes under the, and what's this thing called? Radical. A radical.
A radicand.
Okay? Now, what about this? This one. He's called the index number. And what is the index number telling you? He's telling you what root to take. Okay? What if I don't have an index number there? That's a square root. It's understood to be a 2, but we don't have to write it. If you take any other root besides a 2, you have to tell someone what root you're taking. Okay? That's right. All right. So, here we go. Now we're going to talk about something that you know about, okay? You know about. The nth root of A. The nth root of A. So let's just go over here and let's just play a little bit. What about the square root of 4? 2. Is it only 2?
Plus minus 2.
Okay. It could be a plus or minus 2. Do y'all agree? 2 times 2 is 4. Negative 2 times negative 2 is 4. Everybody okay with that? Okay. What about the cube root of 8?
Plus or minus 2. No, just plus 2.
What is it? Just 2. Okay, just 2. 2 times 2 is 4 times 2 is 8. Well, what if I did do the cube root of negative 8?
2
Yeah, it's just negative 2. Right? Negative 2 times negative 2 is 4, and 4 times negative 2 is negative 8. Okay? Another way some of your brains think about it is if I raise this number to an odd power, he would be negative. But if I raised him to an even power, he would be positive, right? Okay. So what we're going to do is, hey man, we're going to put that into words. Okay? We're going to put it into words. Day 1 or day 2? Day 2. Day 2.
You know, last time I tried to take a test during a class, it was during a pre-count class, I ended up paying attention to the class and not the test.
Last time I tried to...
You're not going to go back.
Yeah. Last time I tried to do a test, it was during 8th period. And... Yeah, but it was the one about the building, the antenna tower on the building.
I got that one right.
Do you guys remember that one? Hey, do you guys remember the... I don't know, I haven't found out yet. Do you guys remember the question about the antenna tower on the building?
Y'all should have told me to pause. Sorry, whoever's listening to the video.
Okay. Pause twice today.
Okay, so, all right. Oh, yeah. So here we go. We're going to write this, and we're going to write it in a mathy way. Okay? We're going to write it real mathy. So watch this. Let's say that n is an even number. Now think about what we're talking about. Okay? Do it in your head. Say it in your head. If n's an even number, what am I talking about?
2.
What? Say it out loud now.
2, 4, 6.
Yeah, but what am I mean, where is n? I'm not just talking about 2. What am I talking about?
I'm going to be 4.
The square root of
The
n.
square root. The fourth root. The sixth root. Does everybody understand? That's what I say. When I say, what are you talking about? Put an even number up here, people. The square root, the fourth root. Okay, so let's see what happens. If A, which is the number underneath, the what?
Radicand.
The radicand. If A is a positive number, okay? If A is a positive number, can you tell me how many solutions you will have?
However many... Yeah, whatever.
2? Y'all agree with Jody? 2 solutions? Why? Because what, Jody?
Plus or minus.
Because there'll be plus or minus. Well, what's the square root of 4? Oh, it's written right there on the paper. Plus or minus 2. What's the square root of 16? Plus or minus 4. Does everybody understand? I mean, let's not make this hard, okay, people? All right. What if A is negative? How many solutions am I going to have?
1.
Wait. A is negative.
2. We've been over this.
2.
1.
If it's even though.
2 solutions?
No.
Because they're going to be what?
They're imaginary.
Yeah, but they're still what?
Plus or minus.
Plus or minus. It's still plus or minus, guys. But yes, they are going to be imaginary. Okay? They're still going to be imaginary. All right, everybody okay so far? Okay, what about, here's our other option. N is an odd number. Now, do the same thing, people. I asked you to kind of think about it, okay? So you ought to be thinking, what are we thinking about? No, what are we thinking about?
Here. We're talking about the nth degree.
What degree?
The nth.
First, third, fifth,
Yeah,
seventh,
do we do first root? No, people, we don't do first root. So what are you talking about? The third root, the fifth root, the seventh root. That's what we're talking about, okay? So what if A, the number in the radicand, is positive? How many solutions? One solution. And what do you know about that solution? It's going to be positive. It is. What if A is negative? How many solutions will that have? Very good. One solution, and he'll be negative. Very good. All right, everybody okay so far? Okay, so let's try a little problem. Let's do example 1.
I think everybody does okay up until this point.
Okay, example 1 says, find the indicated real nth root of A. Oh. They just told us to do kind of what we were doing, right? But they just put some more fluff in there, right? Indicated means that they're going to tell us. They're going to indicate what N and A are, or you couldn't find it, people. Okay? Real means,
non-imaginary.
yeah, my answers must be real numbers, I guess. Okay? So, here's A. Stop tapping. N is 3, and A is negative 216. So the first thing I want you to do is just to write it down. Not like this, but write it down like a problem. What's it going to look like?
216 divided by 3. Wait,
It'll be a negative number.
never mind, ignore me.
Can we just show them off the clip?
What's it going to look like, people? The cube root of negative 216. Come on, guys, you should be able to do that. The nth, look, it says it right here, the nth root of A. Oh, my word, people. The third root of negative 216. Now, what do we know the answer is going to be? A negative number. Why?
Because it's negative.
Because it's an odd root, and odd roots keep the sign of the radicand. That's what that is. That's what that means. So we know my answer is negative. Now, I didn't ask you to know 216. I asked you to remember the cubes up to 5. Yeah. 2 cubed is 8. 3 cubed is 4 cubed, 64. 5 cubed, 125. 6 cubed is 216. So this is negative 6. Okay? And you'll know that because it's going to pop up a few times. Okay? So here we go. Here's your next problem. N is 4 and A is 81. People, you ought to be able to do this in 30 seconds. Okay, you ready? Tell me what it is. No, I don't want the answer. I want you to set it up. The fourth root of 81. Now, how do I take fourth roots? Yes, you do. That's exactly right. You want to take a fourth root? You take a square root and then a square root. That's why I said you ought to be able to do it in 15 seconds. Shh. What's the square root of 81? What's the square root of 9? 3. There you go. That's your answer. Now, oh, plus or minus 3. Why is this one plus or minus? It's an even root, okay? Even roots will always be plus or minus, and odd roots will not. Okay, very good, very good. Okay, so let's talk about something else. Everybody okay so far? Okay, So let's talk about rational exponents. Now, when I say rational exponents, what should come to mind? Very good. No, rational exponents. So we know they're going to be fractions. Okay? Now, this is what one of the kids last period asked me, and I thought it was a very good question. He's like, Miss Davis, when you say rational, I don't know when to think fractions and when to think radicals. Because you remember, a rational number is, or irrational. I think that's what he's thinking about, rational versus irrational. That's a type of number. Okay? Your number is either rational or irrational. So, if it's talking about different things, not types of numbers, then that's when I'm going to think about fractions. So, same rules apply. Do we know the rules? People, we just went over them, okay? So, that's why whenever I teach you something and you don't get it, I go, oh, well, maybe they'll get it next time, all right? But guess what? If you didn't get it the first time and you don't get it the second time, yeah, people, you need to learn it, okay? You need to learn it and remember it so it doesn't just keep kicking your tail all the time. Same rules of exponents apply. Okay, so let's look at an example of what something with a rational exponent might look like. A raised to the b over n power. Is that a rational exponent? Yes, it is. It's just something it's a base, right? He's got a fractional exponent. So, no. No, you don't. Now, what have we been talking about today? What are the two things that we've been talking about today? Roots and powers. Roots and powers, roots and powers. That's all we've been talking about. So, y'all, this must have to do with roots and powers. So, let's think about powers. Powers. Powerful things. Powerful people. Where are they? They're on the top, people. They are on the top. Powerful people and powerful things are on the top. Guess what this number is? He is a power. Do you know how to raise things to a power? Yes, you do. Please tell me you do. It just means multiply this number by itself this many times. Everybody agree with that? Okay, roots. Where do roots grow? In the ground. So this number down here must be a root. Hey, could I write this with a radical? Let's put a little radical here, okay? Tell me what you know.
The B-N of A. The B-N of
Hey,
A.
let's just think. Who goes right here? A. All right. So, hey, who goes right here? Who's my index number? Who's the root? Who's telling you what root? N. The nth root of A. The nth root. The nth root of A. And then what is the B?
It's on the exponent.
Yeah, y'all. He can either go under here, or yeah, he can go outside here. And you would put this in parentheses. So you would take the root first and then raise to the power. Whereas this one says raise it to the power first and then take his root. Which one sounds easier? This one? Why does this one sound better? Because what are you doing to your numbers?
Shrinking and then multiplying.
But what do you, yeah, you're keeping them small. Okay? You're keeping them small. Here, oh my word, you're raising this number to some power. You don't know how big it might get. Okay? And then you're going to try to think of what root of that number. But so I'm going to take the root first. If I can, we're going to take the root first and then raise it to the power. Okay, so let's talk about some that we can look for examples. All right? Here's the first one. This one should be pretty easy. It's going to be crazy. Okay, it's going to look a little crazy, but it's really not hard. 4 to the 1/2 power. Y'all, what's that the same as? Y'all, that is the square root of 4. That's all that is. What root? The square root of 4, and then you're going to raise it to the first power. That doesn't even change it. What's the square root of 4? Y'all, that's 2. Is it plus or minus 2?
Yes.
How do I know when to put the plus or minus and when not to put the plus or minus?
Well, that makes sense. If it's even or no, if it's
No, y'all aren't thinking about what I'm referring to. Okay? If I just said what's the square root of 4, what would you say? You would say 2. You would say 2. Okay? And I'm okay with that. I like that. Okay? Oh, if you're trying to find answers. So, Alex, if you had a problem like this, what is that? Oh, and what? An equation. So remember what the rule was that we learned. If you're solving an equation and you take a square root, then you have to put the plus or minus. So if I'm solving an equation and I take what kind of a root? Not just a square, an even root. Very good. And you solve an equation, you take an even root, you have to put the plus or minus. Okay? So, look, are we solving an equation? No, we're just simplifying something, people, so we don't have to put the plus or minus. Okay? I may kind of jog your memory with it, but we're not going to have to put it yet. All right, so here we go. Here's the next one. Are you ready? Now, what did I tell you to do first? Find the root, and then raise it to the power. Find the root and raise it to the power. Okay, y'all got the answer? What do y'all say?
4.
4? Everybody okay with that? So really, this is what your brain should be doing, right? Your brain should be, I'm taking the root first. So that's the what root? Cube root. So I want the cube root of 8. And then, what am I going to do with that? I'm going to square it. Okay? What is the cube root of 8?
2.
What's 2 squared?
4.
Very good. Now, does my brain do all this stuff? He does like this. He says, hey, the cube root of 8 is 2, and 2 squared is 4. That's what we're doing. Anybody else got a question? Okay, let's do another one. Oh, I don't know.
Many does it take? 6 to 10, she says.
We'll do one more.
I run things.
Okay, everybody got it? What's the first thing you're going to do? Take the cube root of 64. Guys, you're supposed to know this. What is the cube root of 64? And what is 4 to the second power? So my answer is 16. All right, everybody okay so far? Okay, we're going to keep working some more. All right, but before we do, I want to tell you some of the rules. Now, look, do you already know the rules? People, we've been talking about the rules, so you already know them. It's not a big deal. We're just going to write them down. Okay? A to the m over n. Now listen, this is one of the things they're going to ask you to do on your worksheet and the test. People, we're going to call your name out if you miss this. This is crazy. All they're asking you to do is, can I take this rational exponent and write it with a radical? Or if I give it to you as a radical, can you write it with a rational exponent? Those are the two things you're going to have to do. Those are easy, right? Not even any thinking involved. Roots go on the bottom, powers go on the top. Okay? So, let's write this one with the radical. So here's my radical. Who goes underneath?
A.
What's my index number?
M.
What power am I raising it to?
M.
Could I also write it like this? Come on. Yeah. Okay, they're both the same thing. Alright, so what about this one right here? Oh, here we go. Yeah, so all that negative does is say, hey, you better move me. Okay? Have we already studied negative exponents? Yes, we have. We studied them, we worked problems, we had a test. Okay? So, I gotta move it. It's on the top, so I put it on the bottom. There's nothing left up there, so you leave a 1. So that's 1 over a to the m over n. So that's 1 over the nth root of a raised to the m power. Or you can put the m on the inside, whichever way you like to do it. I don't care. Okay, I do have a restriction on this one. A cannot be equal to 0 because division by 0 is undefined.
So what do we do if it comes to that situation?
Then you write undefined.
Oh, yeah.
Okay? It's really hard.
I
Okay.
don't know how to spell.
UNDEF. That's all I need. I know what you mean. Okay, so here we go. Example 2. A. 16 to the 3 halves power. 16 to the 3 halves power. Okay, you should have the answer now, right? Everybody agree?
Yeah.
Tell me what you should have done.
You should have.
The square root of 16, what is the square root of 16? And then you're going to raise it to the, what is 4 to the 3rd power?
64.
That's my answer. Okay, so now tell me this. What if I don't know, just decided to be belligerent and rebellious, and I said, no, Miss Davis, I'm going to cube 16, and then I'm going to take the square root of it. So, here's the problem with that. Remember what we said, why were we doing it in this order?
You keep the number
To
small.
keep the number small, because not many people know that 16 to the 3rd power is 4,096, and, thank you, Spencer. Oh, come on, I don't have time. All right, so is 4,096, and then very few people know that the square root of 4,096 is 64. Now, could I do it that way? Yes. But what would I have needed? A calculator. Before that, have we picked up a calculator? No, we haven't. We've done all of these without a calculator. Okay, so here we go. You ready? Here's the next one. You don't need a calculator. Okay, y'all got it? What y'all do first? You made it positive? Okay. I didn't do that last period, and it made the kids, they didn't like it. I did it last, and they did not like that. Okay, so now it's positive. Now what am I going to do?
Alright, you're gonna work it out.
Well,
You're gonna take the 5th root of
the 5th root, should you know the 5th root of 32?
Yes.
You should. I told you you should. What's the 5th root of 32?
2.
What's 2 to the 3rd?
8.
So it's 1 over 8. Everybody got it?
I was just thinking of it.
That's right.
Okay, let's try this one. Are you ready? All right, you got it, guys?
That's cool. It's like 2 squared.
What are you going to do first?
Take the fourth root of 16.
The fourth root of 16. How do I take the fourth root of a number?
Square.
Square root. What's the square root of 16? What's the square root of 4? So, essentially what I have is 2 to the third power, which is? Okay, very good. Last one. Are you ready? All right, be fast. People, I'm going to give you 15 seconds. 15 seconds. Are you ready?
Aye, aye, Captain. Yeah. No.
Okay, so this is the question that I always get. Miss Davis, are we going to use a calculator on these? I'm like, well, have you needed a calculator? No. And they said, but what if are you going to tell us when we're going to need a calculator? Like, oh, I'm pretty sure you can figure it out. No, I don't think I can. People, how long did it take you to figure out you need a calculator? You understand? Right? There wasn't many people that looked at that and said, the 5th root of 9. Oh, I know what that is. Okay?
It is 1.551.
Between 0 and 2? How about between 1 and 2?
I knew it was somewhere.
Well, 1 to the 5th is 1, right? And 2 to the 5th is 32, people. How many times have I asked y'all to learn that? 2 to the 5th is 32. Okay? So what's it going to be closer to, 1 or 2? 1. 9's closer to 1 than it is to 32. Okay? So let's get your calculators. All right? Hurry up, because we got, oh my goodness, not enough time. All right. So here we go. You can do it one of 2 ways. You can say 9 raised to, I have to put mine in parentheses, but you don't, 1/5 power. And there it is. Or, what else could I put in here? What is that? The 5th root of 9. Y'all listen, you put it in your calculator just how you say it. The 5th root, what's the first thing that comes out of my mouth? 5. So 5, the 5th, and then press math. And see number 5, it'll let you take whatever root you want. Okay? So I'm going to choose number 5, and then y'all will pop it up in that little index number place. Mine won't. Okay? Root of 9, and there it is right there too. Okay? All right, so let's try one more problem. We'll just last one when you come back. Well, we may have time to do both of them. Okay, so here's the first one. The first one looks like this. It's example 4. 4x to the 5th is equal to 128. So now we're solving some equations, right? Tell me what to do. Okay, what's going to be the mistake?
They're gonna do something dumb.
They're going to do what right now? Take the 5th row. They're going to try to take that 5th root right now. You can't do it until you've gotten it all by itself, guys. Okay? So x to the 5th is equal to 32.
Oh,
Now, what do I do? No, we don't. Yes. The 5th root of x to the 5th is x. The 5th root of 32 is
We now
2.
know what question
Hey,
is missing on the test.
plus or minus 2?
No.
Why not?
It's an odd.
Very good. Okay, here's your next one.
Illuminati confirmed. Yum. You already unless they're on a line.
Yeah. Okay, so here we go. Tell me what to do.
How about 4?
Very good. Okay. So x to the 2/3 is equal to 8. All right. Now look, here's the object of the game, people. The object of the game is for me to have an x to the 1st power. What could I raise this to? His what? What's it called? His reciprocal. Very good. Powers to powers are multiplying, so I'm going to raise that one to his reciprocal power, which is 3/2. Thank you. No, Spencer. Oh, the other side, Goose. Okay. All right, right here is what I meant. 3/2. And whatever you do to one side, what? You do to the other. Y'all, any number times its reciprocal is 1. What am I doing over here? Oh, man. I did it backwards, didn't I? Sorry, I made that problem up. It should have been 3/2 over here and then 2/3. Yeah, so we can't really do. You would do a to the 3rd power, and then you'd have to whatever. But anyway, yeah, you have to use a calculator. Yes.